Using the lessons that we learned over the past few videos with our various fruit classes, I have designed an entire family of shape classes. And we can see this class hierarchy is non-trivial. We don't just have shape and a bunch of subclasses. We've got shape, and then rectangles are shapes, and squares are rectangles, which are shapes. So a square is a shape as well. But the class hierarchy has multiple layers. I want to talk about this example in a few different ways over the next few videos. For now, I want to talk about constructors and destructors. So let's meet the shape class that we're going to use today. Like the earlier examples of shapes, the shapes in this file do know their own name. I can ask a shape object, whether it's a rectangle, circle, or square, to tell me its name. The difference is, unlike in previous examples where, for example, with our fruit classes, the getName function was some virtual function that we could override. In this example, it is actually a non-virtual function in the base class shape. Instead, if you want to set the name of the shape, you have to somehow set this member name. So it's a protected member, so it gets inherited by rectangle and square and circle, and they can then set the name. And we'll notice what I've done. For example, in the rectangle constructor, when I want to set the name of the rectangle, I have to say name equals rectangle. And that sets that protected member that's inherited. I'm actually noticing now that we forgot to set name equals rectangle in this default constructor. So that's how we set the name. And then this function getName, which is public in the base shape class, you call that to actually retrieve the name. And then the shape object itself has two constructors. Now, we're going to come back in a future video to the question of whether we want people to be allowed to create these generic shape objects. Or maybe we think that the generic shape class is sort of incomplete. It's mostly meant as a placeholder to represent all of the possibilities, not something that should exist on its own. We'll come back and talk about that later. For now, there are two constructors. They're shape constructor 1 and shape constructor 2. If you call the default constructor, it initializes the name to be this default value, generic shape. If you call the secondary constructor here, which takes a string, it sets the shape's name to be whatever name you provide. And that's one of the things I want to come back to later. I mentioned in the last video that there was something that happened when you construct some derived class. There is some interplay of the constructors of the base class. That is really what I want to talk about the most in this video. In the generic shape class, we can see that there are these virtual getArea, getHeight, and getWidth functions, because I would like every shape to implement these. However, the ones in the generic shape class all return 0 because the generic shape isn't really complete yet. We don't know what shape it is. We're going to revisit this as well. What does it mean if I want all the subclasses to define something that I cannot define myself? Well, that's something we're going to talk about later. Okay, so here's rectangle. We've got the usual rectangle constructors, and they set the name of the object to be rectangle. And then down here, so we've got our overridden getWidth, getHeight, and getArea. Here is our square class. Notice that this inherits all the stuff from rectangle, otherwise doesn't do very much, because it's able to simply rely on the rectangle class. And this notation we're going to come back to in a minute. And then finally, here is our circle class, and we can see we've got our various constructors for circle here. Just like before, I did forget to set the name in my default constructor for circle. And then down at the bottom, we have print shape. So departing from the very first video from this week's sequence, I only have one print shape function. We now know that because all of the various shapes I've implemented, rectangle, square, and circle, are of type shape, I could just pass them all into this function here and just call one print shape function for any of them. And then in main, I've got a construction of rectangle, square, and circle, and then I print all three of them out. Really what I want to talk about, though, is which constructors get called. So I'm going to run the code. And if we take a look at it, there's quite a bit of code happening here, so we'll expand the window. So at the beginning of main, I see there constructing a rectangle. Now this is output coming out of main. This is not the rectangle constructor. The rectangle constructor that I call is the one that takes the 4 coordinates. So I pass in the bounding box of the rectangle. Notice how before I actually arrive at the rectangle constructor, I see a call to the generic shape constructor. And as I mentioned, as I alluded to in the last video to foreshadow this, whenever I construct a rectangle is a shape. It contains various information that is part of a shape, as well as extra information that extends the shape to be a rectangle. In this case, the extra information is the bounding box, the lower left and upper right points of the rectangle. But a shape object also contains a name. That is property of the shape object. Every rectangle object has a member called name, but that's something that it inherits from the base class shape. So the question then becomes, who constructs name? Because we know that name has to be constructed by somebody. Every member of every class must be constructed. Who is in charge? And the answer is pretty simple. The class containing the member is the one that always constructs it. So the rectangle class can use the member name, but the rectangle class is not directly responsible for constructing the member name. And I can prove that by trying something like this. Suppose I want to alter how the variable name gets constructed. I could provide a constructor for it. I could provide an initializer. So I try constructing name, the member variable name, with the value rectangle. And we'll try compiling that. And we can see, sorry, you can't do that. So on line 69, you are not allowed to provide an initializer for the variable name. And the compiler gives a rather odd explanation. Rectangle doesn't have a field called name. But doesn't it? I mean, I was just using it. Didn't I just say name equals rectangle? What the compiler is really drawing your attention to here is that, yes, rectangle does have, I guess, access to a member called name, but that's a member it inherited. The member name doesn't really belong to rectangle. It belongs to shape. Rectangle inherited it because rectangles are shapes. But rectangle doesn't own the member. That's part of the base class shape. The shape class is responsible for constructing it. And that's why, if the shape class has to construct all of its members, even when it's being inherited, then obviously we have to call a constructor for the shape class. And that's why before I can print out that I'm in the rectangle constructor, so on line 69, notice that before I see that, I see a call to the generic shape constructor. Whether or not the generic shape constructor does anything useful, it needs to be called to ensure that all the members of shape that need to be constructed get constructed properly. The same turns out to be true of destructors. The shape class is responsible for the destruction of its members. And that's why at the end we'll notice that a destructor for shape gets called as well. So whenever I construct a derived class like rectangle or square, I also have to call the constructors first for all of its base classes, going all the way down. I start at the top of the hierarchy and then construct every base class all the way down to the class I'm really creating. So when I construct a rectangle, I see a call to the generic shape constructor. Later, I decide to construct a square in main. Notice that that first requires me to construct a shape, so I see another call to the generic shape constructor. And then I construct a rectangle. That's a call to the rectangle constructor. And then finally, I see a call to the square constructor. I think the square constructor doesn't actually print any output. Sorry about that. That was a bit of an oversight. So we'll just add that. This is the square constructor. The output did look a little bit off, so we'll just run that again. There we go. Okay, so now I try to construct a square. There it is. And I see a call to the shape constructor, a call to the rectangle constructor, and there it is, a call to the square constructor. And then later I construct a circle, and I see a call to the shape constructor and a call to the circle constructor. Okay, so whenever I construct a derived class, I first have to call all the constructors for the base classes to construct the members that are going to be inherited by that derived class. Okay, next thing. In main, I call print shape 3 times. The single print shape function that I have that accepts as its argument a shape. Notice how when I pass in a rectangle, a square, or a circle, it is able to understand that each one is different. So although it only knows the apparent type of S is shape, because of the magic of overriding, I can call the get width, get height, and get area functions and get the ones that correspond to the true type of those objects. Notice how the area of the circle is actually valid. So the radius of the circle is 1, the diameter is 2, and that means that I should expect the area to be pi times 1 squared, which is just pi. Okay, so I am able to upcast all of my shapes to the shape type and then pass them into print shape. And then finally at the bottom, I notice the destruction sequence. And so I'll see here I've got my circle destructor and then the shape destructor, because by the law of socks and shoes, when I constructed the circle, I first called shape constructor, then circle constructor. So when I destruct the circle, I will first call the circle destructor and then the shape destructor. I take apart the object one level at a time. And when I put the object together, when I construct it, I go from least specific to most specific. When I destruct the object, I go in the opposite order. When I destruct the square, I notice calls to the square destructor, the rectangle destructor, and the shape destructor. And finally, when I destruct the rectangle, I notice a call to the shape destructor as well. Okay, so hopefully that proves the point to you that when you construct an object of a derived derived class, you first must construct all of its base classes. And when you destruct it, you have to destruct all the base classes after the destructor for your derived class. This question here we're going to answer in a different video. What I want to talk about at the end of this video is, well, wait a minute. So if I know that whenever I construct a circle or whenever I construct a rectangle, I need to first construct all of its base classes, what if I want to have input into how the base class gets constructed? So I know that when I construct a rectangle, there is going to be a constructor for shape that gets called. What if I care which constructor for shape gets called? And I have the option because when I'm constructing a rectangle, I might want input into how I construct the base class. I have the option of specifying how the base class gets constructed. And I've already shown that in this code. So here I have the constructor for square. And I noticed from an earlier example, we observed that we could construct a square out of a rectangle by just creating a rectangle with this as the lower left point and this as the upper right point. And I have a constructor for rectangle that does that. So notice what I'm doing here is, just like we saw last week, that I can delegate construction. So I could have one constructor for rectangle call a different constructor for rectangle. I can also delegate base class construction. In my square constructor, I can say, here is how I want the rectangle to be constructed. Here's how I want my base class to be constructed. And you're allowed to go one level up. In order to construct a square, you first must construct the rectangle that the square is built on top of. You can specify how the rectangle underneath gets constructed, but you're not allowed to skip a generation. So the square can specify how the underlying rectangle gets constructed. The rectangle can specify how the underlying shape gets constructed, but the square is not allowed to go directly up to the generation with the shape because that would bypass rectangle, which does also deserve some control. So here I'm specifying which base class constructor to call by just naming the base class and providing constructor arguments. And so that's why when I construct a square, if we scroll up to the square constructor, notice how it calls rectangle constructor number 2. If you construct a derived class and you do not specify which constructor you want, then of course, a constructor must always be called. So here, I'm not saying which shape constructor that I want, but a constructor must always be called. And so the compiler defaults to the default constructor. If you don't specify which one, it just calls the default constructor, so this one. So then the question is, what happens if I call a different shape constructor? And notice that there is this shape constructor that sets the name of the shape. So why don't we try calling that? I'm going to use circle for this. So here's my circle class. I'm going to position it so that I don't have to remove my diagram from the screen. And I would like, when I construct my circle class, because the circle is a direct descendant of shape, I would like to call the shape constructor that takes a name as its argument. So what I'll do is I'll call the base class constructor, giving it a string as its argument, and then I don't have to do this, because the base class constructor will set the name for me. Okay, so I'll save that, and then we'll try compiling and running it. And before I run it, I want to show off when I constructed the circle. Notice how it calls the generic shape constructor number 1 and then circle constructor number 2. And if I run it now, after changing this, I am telling in the circle constructor, I'm saying, please construct the shape using the alternate constructor, shape constructor number 2. And you can see there is the generic shape constructor number 2. I was able to specify which base class constructor I wanted to use. So as part of the circle having control over how it is created, it also has control over exactly how the base class it's built on top of gets created. And so one more thing I want to talk about while we're on the subject of this construction process. Let's use the rectangle as our point of reference here. So before, like last week when I talked about rectangle objects, I sort of referred to them like this. Rectangle looks like this, its name is R, and it has 2 members, and they are both of type point. How exactly do we diagram, if we have to do so, the process of constructing a rectangle where its base class is shape? In particular, what happens with this inherited data? So the way I want to draw that out, if I had to diagram it, and I should be clear, for tracing, I probably wouldn't do this full diagramming, but it is useful to think about conceptually how we would draw it. So a rectangle is a shape. And the way I want to think about it really is that a rectangle is an object that's built on top of a shape. It's built on the foundation of a shape. So every rectangle starts as a shape, and then I build extra stuff onto it. You might think about that inside the object as there's the sort of initial layer, the part that's contributed by the base class shape, and that contains, let's see, well, the shape brings with it a data member called name. So inside the part that's provided by shape, I get a member called name. And that gets constructed for me by the shape class. The rectangle is then built on top of that part. So it's a shape plus extra. So I first construct this layer, the foundation of the object. And then on top of that, I add the members for rectangle. So down here in the actual rectangle part, I have my point lower left. I'll just call it LL. So there's lower left, and I have my point upper right. And so when I finally get into the rectangle constructor, after the foundation has already been laid, the rectangle constructor can decide how to construct these things. If I were to have a square, we might think of a square as looking sort of like this. I'll just doctor the rectangle diagram to illustrate my point. So here's my object of type square. And a square consists of a square is a rectangle, and a rectangle is a shape. So a square now just has an extra layer here. It first has the initial strata of a shape, and then it has this layer of all the stuff that corresponds to a rectangle, and then finally at the bottom it has all the stuff specific to a square. To construct a square, I first build the foundation, I first build the shape, then I build a rectangle on top of that, and then finally I finish it off by doing whatever square needs to be constructed. And so that's the idea, is that each class, even when it's acting as the base class of something else, does still get agency, does still get control over its own members. Sure, the members might be inherited by derived classes, but the class itself still gets a lot of control over how those members are created and how those members are used. Now, what I want to answer now in the next few videos is a few questions about this big family that I just created. So for example, I've got this class called shape that isn't really meant to represent anything on its own. I don't think I want any just shapes in the world. I want to use type shape as a way of referring to any shape without referring to any shape in particular. But I don't want objects of just type shape. I don't want generic shapes floating around. So the question then is, what should we do to prevent anybody from ever creating a generic shape themselves? They're allowed to create rectangles, squares, and circles, but they should not be allowed to just create something of type shape. Because we can think of the class shape as being sort of incomplete. Its job is to provide an abstraction, something with a width, a height, and an area. But it's sort of an empty shell. It has not provided the abstraction. It is just an empty shell that can be filled in by a subclass. So I might want to prevent other, like the outside world, like main, from constructing just generic shape objects by themselves.